Hello everyone, welcome back to Aaron's Shop Notes. Today we're going to be building a rolling base for the Bridgeport. So let's take a look at the problem we're trying to solve, and I'll show you the design I came up with and how we're going to do it. So as you can see, this is where my Bridgeport sits right now in the shop. It's shoved back into this corner, along with a whole bunch of other stuff. All of my metal stock down there, my bandsaw, my horizontal bandsaw just sitting in the corner here, and my VFD is mounted to the wall, along with my only 240 volt outlet back there. And I want to be able to move it around. When you have a small shop like this, it's important that you can shimmy things around to get things into position, move it where you need to, get behind it, clean up chips behind it. So that's the plan. We want to build a base for it that'll allow me to move it when I need to, and will be sturdy when I don't need to. Right now it's on very unlevel concrete, and the whole thing rocks and shakes the entire time that I'm moving it. The entire time I'm cranking the hand wheels, it's rocking back and forth. Chances are this isn't really affecting the quality of the part. It's not like a lathe that needs to be leveled to use it, but it is unpleasant to use, so we're gonna fix that, and we're gonna make it so it can roll around at the same time. So let me show you the design I came up with to do this. All right, so for those of you that don't know what we're looking at, this is a CAD software called Onshape. Onshape is a free CAD software, at least for hobby use, like, kind of like Fusion 360. And the biggest difference between CAD, Onshape, and the other CAD software is that Onshape is fully web browser based. So the advantage of that is that I can work on something in the shop on my laptop, work on the modeling, do all of that, and I can come up to my computer, make changes there seamlessly without any issues switching between the two. I can also pull it up on my phone or an iPad to at least look at dimensions. You're not really going to do any modeling like that. Now, some of you may be saying that that sounds bad because then it's going to be slow running in a browser, but that has not been my experience at all. I have a very nice computer, and this runs better for me than SolidWorks does, than Fusion 360 does. I think it's just very well optimized. It's also very similar to SolidWorks. The creators of SolidWorks were involved in making this, original creators, so there are a lot of similarities. I think give it a try if you haven't tried it before and are looking for a new CAD software. It's really nice. So into the design, I mocked up just the Bridgeport base here, roughly. The important thing are the hole dimensions, which I got right. And what we're going to be working with is this sort of outrigger design with leveling casters, these leveling casters here. So what these are, I'm sure you've seen them before, but they have these casters that and a ratchet mechanism for the feet, so the feet can be lowered down to be used to level it. But when you want to move it around, you can raise the feet and it drops onto the casters. So you can move it around, and then when you want it to stay in place, you have a nice stable feet base. They are rated for 6,600 pounds. Do I believe that? Probably not. But the Bridgeport is only 2,500 pounds, so there's a healthy safety factor there that I'm comfortable with. I would have loved to use some genuine Footmaster casters, but those are expensive and we're not in the budget this time. So this is what we're working with. Like I said, I went with this sort of outrigger design where I'm going to put the casters on the outside. Reason being, I think we can use all of the extra stability that we can get, especially if we're trying to roll this thing around. Even on concrete, it can be a little sketchy. The Bridgeport is very top heavy. So added stability from increasing it, the distance there. The other advantage that we get with this is that if you take a look at the sketch, this 27.25 here, this is the width of a typical pallet jack, and then these 7.25 is the fork width. So what that means is that we have the casters for movements around the shop on concrete, but if we ever need to move it a further distance, we can now fit a pallet jack under it, and we can fit a forklift under it without an issue. So that will be a more stable way to move it if we need to move it across any sort of non-concrete, non-level ground. So what we're going to do is we have these two holes. These are 20 inches apart on the Bridgeport base. They're just through holes into the casting. If you're going to do this, measure your own holes. I've heard that some of them can be 19 inches apart, so double check that for your own. Those will be tapped M14 holes. Reason being is, like I said, we want to be able to get a pallet jack or a forklift under here, so I didn't want nuts protruding on the bottom. So those are tapped. The bolt will just come through the housing and bolt into these plates. And then we have this same 4-bolt M10 pattern, which matches the hardware that these casters include here. So those will bolt in up through it. And yeah, that's the plan. So let's go take a look at the hardware we have and let's see what we're working with. So here's everything we're working with. We've got our stock, which is 36 inches long, almost perfectly. They did a pretty good job cutting it. And then 4-inch by 1-inch rectangular stock. We've got our casters. These are absolutely massive. If I had any worry about them being good enough for the weight of the Bridgeport before, I'm not anymore after seeing them. Now, the pattern on these is 70 millimeters hole to hole, square, and then overall it is 95 millimeters. So my plan, according to the CAD I've got pulled up over here, is I'm going to have it offset about 1/4 inch from each side. And these are M10 bolts, so I'm just going to thread in through it. Just get it through holes. I've got my M14 bolts, which will go 20 inches center to center, as I said. And yeah, that's the plan. So I originally intended on squaring up this stock since it's hot rolled, throwing it in the mill, squaring it up before I went ahead and painted it. That I don't think I'm going to do anymore. The reason for that is because it is 36 inches long, which is the full travel of my Bridgeport. That would be very difficult to do. So I think what I'm going to do is I'm going to leave it as the mill scale on it, and I've got this self-etching primer and this high performance enamel. So I think the self-etching primer, if I clean off with acetone pretty well, I think this will make it stick, the enamel stick pretty well. So I'm not too worried about that. So plan, stick it in the mill. For each side bolts, what I'll do is I'll just center this portion over the vise, just have the back side supported with machinist jack, and then we'll drill the holes and tap the holes on for the end. Again, the spacing of these two legs, these 2 feet, doesn't really matter, so we'll just edge find off the edge. It doesn't matter what the exact distance is. The only distance that matters is the 20 inches on center, and for that we'll use one setup. So let's go to the mill and let's get some holes drilled. Alright, so here's what we're working with. I got it supported on one side with the vise. I got a machinist jack on this side, and I have it tapped down onto parallels, so we know it's fairly straight. It's not a precision application, it should be fine either way. So what I'm going to do is I'm going to go ahead and edge find the center of this, find the edge of this, and I'll just make the 4 tapped holes, flip around, do the back side, and then we'll make the 2 tapped holes in the center. All right, here's the setup we're working with to drill the two holes, mounting holes, the M14 holes. What we did here was I just centered it up on the vise, and then I put two machinist jacks close to where we're gonna be drilling. And then to find the location, I just measured the location of one hole, set that as my 0, then I'll go 20 inches over in the same setup. Is it gonna be perfectly centered? No, it might be off by, up to, I'd say, a 1/16 from these holes to these holes, but that doesn't really matter in this case. So that's what we're doing here. All right, many hours later, here's what we're working with. We got a lot of tapped and drilled holes. So what I'm gonna do now is I'm going to get these cleaned up, rub down with acetone and wash them. And then I'm gonna spray them with self-etching primer and then some enamel paint. And we'll check back in after that. All right, here's the plan. Somehow we need to get the Bridgeport up on blocks. I don't quite know how I'm gonna do it yet, but it's gonna involve this big leverage bar and these blocks. We're gonna figure it out. But if things go horribly wrong, at least you know what the plan was. So I think first step is I gotta get it out of that corner. All right, y'all, we want the good news or the bad news? I guess we'll start with the good news. We got it. It's done. The bad news is that, as you saw, the camera died while I was in the middle of doing it. So, now, luckily, you didn't miss much. You missed about 3 hours of me messing around with this. This was way harder than I anticipated. First, I tried to just use the big old crowbar, the leverage bar, and shimmy blocks under it little by little. And that wasn't really going anywhere. I wasn't getting enough height, and I couldn't get behind it because of how close it was to the corner. So, next thing I tried, the engine hoist. That also didn't work because this thing is tall and awkward, and I guess past the lifting capability of this thing, because you got to have it pretty much all the way in to be able to lift the full weight of the Bridgeport. And so you can't really get over the center of gravity here. It's just awkward. You might have been able to make it work if you maybe like rotated ahead or something, but it felt sketchy. So I went back to the pry bar. Man, words are hard. And the thing that ended up working is this engine jack, or sorry, this car jack. So what I did was I would use the pry bar, get a block under it, use the pry bar again, get another block under it, shimmy it up until it was, high enough that the engine, the car jack would fit under it. Then I used the car jack to lift it up a little more, and then shoved this big block under it. Once that big block was under it, I could go a little more with the engine, with the car jack. I keep saying engine, shove another block on top of that block until eventually the front side was tilted far up, back side was still on the ground, and then I was able to get the front bar levered, the front foot bar on it. Then it was rinse and repeat for the back. Leverage bar, crowbar to get a block under one side, then the other side, and then eventually I was able to get the jack under it, get a longer bar under it, and then eventually it was high enough that I could get the feet under it. Now, that one sucked because I had to keep moving left to right because there's no room to get behind it with the jack. So I had to keep switching sides. This was probably about a 3-hour process in general. If you are thinking about doing this yourself, just know that that sucked, and hopefully you have a forklift or a better way to do it than I did. It also did not feel very safe. It felt like this thing could tip at any moment. Maybe that's just being overly cautious, but overall, I think it looks great. It's not easy to move around, but it does roll. It takes some weight to push it, which I think is good. And when it's on the casters, or when it's on the leveling feet, it's sturdy. It's not going anywhere. And one thing I anticipated, but I didn't realize it would be this bad, was this thing is pretty high now. I'm probably gonna need a little platform to stand on while working. I'm 5'9", and I think this added about 5, maybe 6 inches. So it's not a small amount. But I think it was worth it. I can pretty easily roll this thing around anywhere in the shop now, and that is very helpful. Honestly, I might start using it in the middle of the shop. My original intent was to leave the space open so I could park my car inside. My wife always gets her spot, of course. But, I wanted to put it in that corner because that was the only place where that was an option. But now I can machine within the center of the garage like I want to. And if I ever want to move it back, it's super easy. So I think this unlocks a lot of possibilities. It was a more in-depth project than I expected. Tapping and drilling all those holes took a while. Getting it up on blocks to attach it took a while. Painting it ended up taking a while, but it was fun. It was a fun first major project for this channel, and if you want to follow along, I encourage it. I think this was a good project to do, and if you want to be able to move your mill around, I don't think this is a bad option. All right. I have some cleaning to do. As you can tell, that left a little ruin in my shop. So gotta find a new place for the metal stock. I gotta remount that control box so I can actually open it while the mill is in that corner because I want to shove it back a little further. And I gotta put all this stuff away. All right, that's a wrap. I hope you enjoyed watching. I had a lot of fun doing this project. If you're interested in doing it yourself, I'll have drawings. There's much to the drawings in the description, and I'll have a link to the casters that I used. Again, thank you for watching. If you enjoyed, please consider subscribing, liking, and commenting. Any interaction is appreciated. Thank you, and see you next time.